Hey everyone, so today we are going to be simplifying algebraic expressions. So the first thing that we need to remember is the order of operations, because we're going to be applying the order of operations when we simplify expressions. So I'm sure you remember this from either elementary school or middle school, PEMDAS. P stands for parentheses, and remember that means what's inside the parentheses, not what is outside the parentheses, so you're supposed to simplify whatever's inside the parentheses first. Then you check for any exponents. If there's any exponents, you're going to simplify those exponent values. Then you're going to check for multiplication or division. And you can see that this is grouped together for a reason. It's whichever one comes first from left to right. So as if you're reading a sentence from left to right, if division comes before multiplication, you do the division first because that's what comes first from left to right. And then lastly, addition and subtraction, same concept. These are grouped together because it's whichever one occurs first when you're reading it from left to right. So when simplifying expressions, we use the order of operations and rules for polynomial operations. So order of operations, which is PEMDAS, and then the rules for polynomial operations, which is what we've covered in the last 2 weeks. So adding polynomials, multiplying polynomials, we need to be able to remember all of those rules to the expressions that we're going to be simplifying today. So this says simplify the expression below. So let's take a look. All right, so we know in order of operations, parentheses comes first. But remember what I said before, it's what's inside the parentheses. So if we take a look inside the parentheses, x plus 5, we cannot add x and 5. We don't know what x is, and it's not like this doesn't have an x, so they're not like terms. We cannot add these together. So please don't write 5x, because x plus 5 is not equal to 5x. So the first thing that we're going to do is we see this 3 on the outside of the parentheses. That represents multiplication. So we are going to multiply. We're going to distribute. So I'm going to take this 3 and I'm going to distribute it to inside the parentheses. And that's going to give us 3x plus 15. Please note I did not distribute to that 8 because the 8 is not inside the parentheses. It has to be inside the parentheses for this. Now we have 3x plus 15 plus 8, 2 sets of additions. So remember, we work from left to right, but we're not able to add 3x and 15. They're not like terms. So we have to combine our like terms, which in this case is this 15 and this 8. When we add 15 and 8, we get 23. And then we're going to just bring down that 3x from before. And same thing, we cannot combine 3x and 23. They're not like terms. This does not have an x, so we can't combine it. So we're done. So we distributed that 3, and then we combine like terms. Let's take a look at another example. Simplify the expression below. We have 2m times negative 4m to the 4th minus 3 times negative 5m to the 5th. So we have some subtraction here, and we have multiplication. So we're going to do multiplication first. That comes first in our order of operations. So I'm going to first multiply this 2m and this negative 4m to the 4th. I'm not really distributing here because it's not like there are multiple terms inside these parentheses. It's not like an x plus 5 before, it's only one term. So I'm really just calling it multiplication in this sense, just so you know the difference between distribution and then just multiplying. So remember, when we're multiplying monomials, we multiply the coefficients, the numbers in front, and then we add our exponents. So if you need a little refresher, we know that there's an invisible exponent of 1 there. So we're going to multiply 2 and negative 4. That gives us negative 8. And then we're going to add our exponents, 1 plus 4. Let me just circle those so you know exactly what I'm adding. 1 plus 4 is going to give us 5. Now, I didn't do anything else, so I'm going to just bring this down for now. And the more comfortable you get with this, the more steps you're going to be able to do at once, but I just want to separate it as much as possible. Now we have the subtraction here, but we still have multiplication. And remember, multiplication comes first, and we're not able to subtract these anyway because they're not like terms. So we're going to have to multiply this negative 3 and I'm treating it like a -3 on purpose, and this -5m to the 5th. So I'm going to multiply -3 and the -5m to the 5th. A negative times a negative gives us a positive. 3 times 5 is 15. And this 3 didn't have any m's, so I don't have any exponents to add, so that m to the 5th stays the same. Now I'm going to just bring down that -8m to the 5th from before. And now we have two monomials, -8m to the 5th plus 15m to the 5th, that are like terms. We know that they're like terms because they have the same variable and the same exponent, so we can add these together. So remember, when we add monomials, we're just adding the numbers in front, and we're leaving the exponent alone. So please do not add the exponent here. We only do that when we multiply, like what we did in this first step. So -8 plus 15 gives us 7. And we're going to just leave that exponent alone. So we get 7m to the 5th. Okay, let's take a look at another example. Simplify the expression below. 2p minus 4p squared plus 5p minus 5 times the sum of 2p squared and 20. So we have two sets of parentheses here. We have numbers outside the parentheses, a bunch of operations going on. So let's just see what we can do first. So remember, in order of operations, we do what's inside the parentheses first. But take a look. Inside our parentheses here, we cannot add anything because they're not like terms. And the same thing goes for what's happening over here. These are not like terms, so I cannot add those together. So the next thing we would look for is exponents. These exponents we can't evaluate because we don't know what p is. And that brings us to the next step, which is multiplication. So I'm working from left to right. So I'm going to do this multiplication first. And I'm going to just do it step by step. So one distribution at a time. So I'm going to take this 2p and I'm going to multiply it to -4p squared, and then I'm going to multiply it to that 5p. So remember, you're going to, actually, let me just put that in a different color. So we're going to multiply the numbers in front and add those exponents because they have the same variable. Okay. 2 times -4 is going to give me -8. And then I'm going to add this 1 and this 2, so that's going to give me p to the 3rd. Now I have 2p times 5p. 2 times 5 is 10, and these are both positive, so that's positive. And remember, we're going to add those exponents. 1 plus 1 gives us 2, so we get p squared. Now, I didn't do anything with that second set. For now, I'm going to just bring it down. And like I said before, the more comfortable you are with these expressions, you'll be able to do those distribution at the same time, but I just want to show you it step by step. So all we did was distribute this so far. Now, we see this 10p squared minus 5, but we can't do anything with that. One, because we still have multiplication going on, so we have to do that first, and these are not like terms. So the next thing we're going to do is we're going to take this -5, and we're going to distribute that to everything in the second set of parentheses here. So we have -5 times 2p squared. This doesn't have a p, so we don't have to worry about adding any exponents here. So -5 times 2 is -10. And I'm going to just bring down that p squared. And then we have -5 times a positive 20. That's going to give us a -100. Okay, I'm going to bring down our product from that first distribution. And then we're going to see what we can do from here. So we got rid of all our parentheses. We got rid of our multiplication. So now we're going to look for like terms. So remember, like terms means same variable, same exponent. So we notice here that our like terms are 10p squared, positive 10p squared, and -10p squared. Now, when you add a positive 10 and a -10, when you add that together, those are additive inverses. So they're going to cancel out and just give you 0. So in this case, these are going to cancel out so that the p squareds are included in that. They cancel out. So then our answer is just -8 p to the 3rd doesn't really look like a p. Okay. P to the third minus 100. Put our answer in a box, and that's it.